A few days ago, I had a discussion about the use of AI in academic writing in a fairly large science forum on Facebook. And I was genuinely surprised by how different people's views were. Not that scientists disagreed. Scientists disagree about everything. That's basically the part of the job description. But the range was impressive. For some people, using ChatGPT to improve English in a scientific paper is completely normal. For others, it seems to be somewhere between scientific misconduct and the beginning of the collapse of civilization. And then there are people going much further and using it for coding, statistics, brainstorming, teaching, literature search, sometimes quite extensively. So clearly, when we say somebody is using AI, or more precisely here, using large language models, we may be talking about very different things. And I think that distinction has become slightly lost. Partly because AI is slowly becoming another culture war topic. And perhaps even more importantly, it's becoming part of people's identity. Some people increasingly define themselves as being against AI. Others define themselves as being on the side of AI and progress. And once that happens, the actual technology almost becomes secondary. On one side, AI is the embodiment of all evil. It steals our work, destroys our brains, consumes the planet, and will eventually replace us with a data center on Mars, presumably owned by Elon Musk. On the other side, AI is apparently an omniscient digital god that will cure cancer, solve physics, and eventually make money obsolete. Both positions are not particularly useful, because underneath of all this, it's still just mathematics running on computers.
Everything's computer!
Very impressive mathematics. But perhaps stochastic gradient descent does not need to become part of our political identity. Once the technology becomes part of someone's identity, evidence stops moving the discussion very much. You are no longer discussing whether a particular tool is useful for a particular task. You are defending your tribe. So I think we should probably calm down a little and look at what these models actually are, how they can be useful, what the limitations are, and what they may change in science. And I should probably declare my bias early. I'm quite bullish on LLMs. I will mostly call them LLMs, by the way, because AI now means almost anything involving computer that does something interesting. I think LLMs are going to become a normal research tool. And I think scientists who learn to use them well will have an advantage over those who don't. But that should not mean outsourcing your brain. And if you stay until the end, I will also get into the ethical problems, because there are quite a few of them. I just don't think the solution is to throw away the entire technology. So, what is an LLM actually doing? At the most basic level, a large language model learns statistical relationships between pieces of language. You give it a sequence of words, and it predicts what likely comes next. During training, it does this on an enormous amount of text and adjusts billions of internal parameters. Do this enough times, on enough information, with sufficiently large model, and something rather strange happens. The system becomes very good at predicting language that looks as if somebody understands what they are talking about, which is, to be fair, is actually quite a useful skill in academia. And the output can be surprisingly sophisticated. This leads to two slightly silly arguments. The first is, it's just predicting the next word, which is true, but the word just, it's doing quite a lot of work in that sentence. The second is, it understands things just like we do. I don't think we need to assume that either. Personally, in my work, I am not particularly interested whether ChatGPT genuinely understands what the heart attack is. What matters to me is whether it can help me to think about a study of heart attacks in a useful way. For example, can it suggest an appropriate statistical approach? Can it point out a possible confounder? Can it show me an alternative interpretation I had not considered? And most importantly, can I check whether those suggestions are correct? That is the distinction I care about. For scientific use, an LLM output is not an evidence. It's not an authority. It is suggestion, sometimes an extremely useful one. So what are we actually outsourcing? A lot of the argument about LLMs in science becomes confused because we use the phrase using AI for completely different things. Suppose I give it a paragraph I wrote and ask, can you fix the grammar and improve the flow? That is one kind of delegation. Now suppose I ask, here are my results, what alternative explanation should I consider? That is another. Or, here are my data, decide what they mean and write me a discussion. That is something else again. This should obviously not be treated as equivalent. I think one useful question is, how much of the intellectual work am I actually delegating? And this differs between tasks. It probably also differs between disciplines. This was one thing I perhaps underestimated before having this discussion. In fields such as philosophy, for example, developing an argument through the language may itself be a substantial part of the scholarly process. You start writing something, you try to formulate it precisely, you discover that the argument does not quite work, you reformulate it, and through that process the idea itself develops. If you outsource that entire process to an LLM, you may genuinely be outsourcing part of the research. So I can understand why people working in such fields may be more cautious. In biomedical research, where I work, the balance is somewhat different. Much of the scientific product exists outside of the final text. We recruit patients, we collect tissue, we sequence DNA, we measure blood parameters, we perform experiments, we analyze data. And nature has slightly annoying habit of deciding what that result will be. If my experiment produces nothing, there is currently no LLM prompt that changes that. Although I assume somebody in Silicon Valley has opened a startup working on that solution. I heard that Elizabeth Holmes' former partner apparently now has an AI company, so who knows. Oh, for those who do not remember Elizabeth Holmes, she founded Theranos and discovered that fake it till you make it is certainly a limitation in medical diagnostics.
This is what happens when you work to change things. First they think you're crazy, then they fight you, and then all of a sudden you change the world.
The language I use to describe my results is of course still important. And writing can be absolutely part of thinking. I have often written something down, and only once I saw it on a screen I realized that the logic did not actually work. So yes, writing things down is useful. But not all intellectual friction is a productive friction. Spending an hour deciding whether the association may actually reflect confounding can improve the science. But spending 20 minutes deciding whether to put the word however in an English sentence probably does not. And this is particularly obvious to me because English is not my first language. Really? Which you probably may noticed. For me, LLMs were genuinely a game changer. I could usually write a scientific idea quite quickly, methods, results, arguments. Technically, the text was more or less fine. But turning that into polished English that was also pleasant and easy to read could take longer than writing the actual scientific content. Now that part can take minutes. And I don't think removing that barrier makes the science worse. If anything, it removes one rather arbitrary advantage from people who happen to have been born speaking the language in which most of the scientific literature is published. For a lot of researchers from non-English speaking countries, this is not a negligible benefit.
Go out there and check someone's privilege.
So why am I quite bullish on it? In my research group, we use LLMs quite a lot. And it certainly does not stop at writing. We use them for coding, brainstorming, explaining unfamiliar methods, debugging, challenging interpretations. And one thing I have noticed is how discussions with my students and colleagues have changed. They have moved one level upward. We spend less time on discussing why the line of the Python code does not run. Python, accidentally, is a programming language, apparently named after Monty Python. We spend less time fixing grammar, less time finding the missing bracket or logical bug that ruined somebody's afternoon. And we have more time to discuss. Does this analysis actually answer the question? Why do these patients behave differently? What biological mechanisms could explain this? What analysis would distinguish explanation A from explanation B? That seems to me like a progress. I do not particularly need a PhD student to develop a deep emotional relationship with the R syntax. R is another programming language. They simply call it R. I need students to understand the analysis. there is also another effect that I think may become very important. LLMs reduce the cost of moving between fields. A biologist can understand and use an unfamiliar computational method more quickly. A computational scientist can ask very basic biological questions without first reading 3 textbooks. A clinician can get code working without becoming a software developer. That does not make them experts in the neighboring fields, and it certainly does not mean that they should stop talking to actual experts, but it lowers the barriers to entry. Science is increasingly interdisciplinary. Anything that makes communication between disciplines cheaper and easier may be surprisingly valuable. But why do LLMs sometimes produce complete rubbish? One criticism I hear quite often: I tried ChatGPT and it produced crap. And yes, it can, quite spectacularly. But there is an interesting problem there. The quality of what you get from an LLM depends heavily on how much you can bring into the conversation by yourself. If I discuss something in field I know well, I can take the conversation very far. I can give it the relevant context. I can ask much more specific questions. I can push back on an assumption. I can ask it to compare several explanations. I can tell it why one interpretation is biologically implausible and ask it to reconsider. And suddenly I am not getting generic textbook answers anymore. I am using the method to explore a much narrower and more sophisticated problem. If I know almost nothing about a topic, I can ask a vague question and receive 5 beautifully written paragraphs of polished ignorance.
In Springfield, they're eating the dogs, the people that came in. They're eating the cats. They're eating the pets of the people that live there. And this is what's happening in our country.
That is dangerous, because a beginner may not know what they do not know. They may simply assume the answer is correct because it contains words like multifactorial. So there are really 2 sides to this. LLMs can multiply expertise. They can also multiply ignorance. Someone who knows very little can produce something that looks much more knowledgeable than it actually is. That is probably one of the biggest risks. And it is also why I don't think LLMs make expertise obsolete. Quite the opposite. In many situations, expertise becomes the thing that allows you to extract much more value from the tool. That is not entirely new. We already use layers of abstraction everywhere in science. When I run function in R, the programming language, even if I understand what my code does, normally I do not inspect every line of the package it came from. I do not expect every dependency, and I certainly do not check what each transistor in my MacBook is doing. I have other hobbies. The important thing is not understanding every layer underneath the tool. It is understanding the layer where scientific validity is decided. If I use a statistical model, I need to understand what question that model answers, what assumptions it matter, what would make the results misleading, and what conclusions I can reasonably draw. If an LLM writes the code for that model, I may no longer need to know every details of the syntax, but I still need to understand why that model is being used and whether the output makes sense. The typing can be delegated, the scientific responsibility cannot. So what should we teach students now? And this is, I think, genuinely difficult. Universities now have to decide what students still need to do by themselves. Should students remember syntax? Should they be able to write code without an LLM, but with Google? Can they use ChatGPT? Can they use an integrated coding assistant? How much code do they need to understand line by line? I don't think anybody knows the final answer yet. 20 years ago, remembering the exact syntax was valuable. Then Google made remembering syntax less important. Stack Overflow made it less important again. Now I can describe what I want in fairly ordinary language and receive code that often works. So perhaps the skill we should increasingly test is not can you produce this code from memory, but can you explain what this analysis does? Can you recognize when it is wrong? Can you test it? Can you defend the choices? At my university we are already moving in this direction. We now use different levels of permitted AI use depending on what an assignment is actually supposed to test in the student. And I think this makes much more sense than one universal rule. If I'm testing basic knowledge or whether somebody can independently construct an argument, restricting LLM use may be entirely appropriate. If I'm testing whether somebody can correctly analyze a biological dataset, perhaps the important thing is not to whether they can personally type every bracket. And once students move into realistic assignment, internships or research, I think there is also value in letting the tools resemble those that they will actually encounter in the field. Otherwise, there is a danger in the other direction. We may become very good at testing how people work without AI while preparing them for a world in which almost nobody works that way. The difficult part is making sure students learn enough fundamentals before outsourcing them. Because if you never learn the basics, you may have no idea when the machine is wrong.
They're eating the dogs.
The sensible balance will probably depend on what we are trying to teach. For basic courses focused on foundational knowledge, there may be very little reason to use LLMs. Once students are expected to apply that knowledge in realistic situations, the permitted tools should probably move closer to what is normal in that field. And we are trying to work all of this out while the technology changes quite dramatically every 6 months, which is very convenient. Of course, there are real problems. Yes, there are. LLMs hallucinate. They invent references, they can produce very convincing nonsense. And because the writing is fluent, the nonsense can sometimes be very dangerous, much more than on the ordinary nonsense, because ordinary nonsense occasionally has the decency to look like nonsense. There is also a much bigger systemic problem. LLMs have made producing a large amounts of scientific-looking text extremely cheap. Academia did not exactly have a shortage of papers before that, and the paper mills operations producing fake or largely fabricated papers, for them this is obviously very useful technology, unfortunately. Generating 20 pages of plausible scientific text used to require at least some effort. Now it can be absolutely automated. That is a real problem. But I don't think the existence of fraudulent use means that legitimate use should therefore be rejected. Email also made producing and distributing spam dramatically cheaper. We did not conclude that legitimate email has become unethical. The problem is the fraudulent activity, not the fact that the same technology can also be used morally and in a good way. And then there are broader ethical questions: copyright, training data, energy use, water, labor, privacy. The concentrations of enormous technological power in a small number of companies. These are legitimate issues. I just don't think they imply that the underlying technology must be therefore not used. They should influence how we use it and which system we choose. And I suspect this part will become easier over time. We are unlikely to live permanently in a world where one single company provides all the AI. There will be competing commercial models, open models, locally run models, institutional systems. Different providers will make different choices about privacy, training data, energy, transparency and price. And then we can choose. We already do this with other technology. If I don't trust Google, I don't have to use Chrome or Google Search. If I dislike one cloud provider, there are others. If privacy matters enough, some things can be run locally. Competition does not magically make technology ethical, of course, but competition gives users, universities, governments some leverage. And hopefully over time it allows us to favor systems that behave better. So maybe we should just calm down. I suspect that in 5 or 10 years a lot of this discussion will look slightly strange. LLM-like functions will be probably embedded in word processor, statistical software, search engines, coding environment and laboratory software. And we may stop asking, did you use AI? Because the answer will be somewhere yes. The more useful questions will be, was the science valid? Can you explain what you did? Can somebody reproduce it? Did you verify the important claims? And who takes responsibility if that goes wrong? The last part matters. The researcher should still be responsible. I do not want an LLM blindly deciding what scientific question is worth pursuing. I do not want it blindly deciding what my experiment means. And I definitely do not want to submit a paper I do not understand because a chatbot wrote something that sounded impressive. But grammar, routing code, finding bugs, explaining unfamiliar methods, generating alternative hypotheses, pointing out weaknesses in my argument before a reviewer does? Yes, please. And perhaps the most important thing is to get out of the tribal mindset. If I had to caricature the discussion, maybe 10% of people think AI is Satan and the other 10% think it's Almighty God. And the remaining 80% would simply like it to fix their Python code. Those numbers are obviously completely made up, which is perhaps appropriate for a video about LLMs. But to get to the point, there is a very loud anti-AI extreme. There is a very loud uncritical pro-AI extreme. And between them, it's a much larger and healthier position. These tools are powerful. They are useful. They have real problems. We should understand those problems and should regulate what needs regulated. We should choose better providers when we can, and we should learn how to use technology without outsourcing the part of science that actually matters. AI is a tool, a rather unusual tool that sometimes lies to us with extraordinary confidence, but scientists already have colleagues who can do that as well. The technology is here. It will improve, the rules will improve, hopefully our ability to use it will improve as well. But waiting for LLMs to disappear is probably not a research strategy. That's all I wanted to say about this matter. If you like this video, please subscribe. And if you are interested in another academic problem we have not solved particularly well, I have a look at my previous video where I discuss whether simply paying reviewers would actually fix peer review process. And yes, I use an LLM while preparing this video, obviously, but I remain responsible for all the nonsense. Bye.